right, so we're looking at problem 3, and this is just going to be the first part. And so here we're testing the spring constant of a spring, and we find that compressing the spring requires a certain amount of force. So we're going to compress the spring, and I'm just going to go ahead and say, my spring compression is delta X, and in my case, it's 19.9 plus or minus 0.199. And all of this is centimeters, okay? And we have ourselves a force that is 23.2 plus or minus 0.232, all right, centimeters. So this is we are trying to calculate the spring constant. So the spring constant is just going to be, and if you guys remember Hooke's law looks like this. It says that the force is equal to a negative K times delta X. We don't really have this, the negative K just means that the force is acting against the direction in which you're applying the force. So it's a reactionary force. So we're not really concerned with the negative sign. So I'm just going to say that this is going to be delta, this is going to be F over delta X. So what is that? In our particular case, I have 23.2, and this can't be centimeters here. This has to be newtons, okay? Newtons. And then we have 19.9 centimeters. Now, we can't do the centimeter thing. We have to put this into proper units. And so we have 100 centimeters per 1 meter. So, of course, that means that our centimeters will be defined as 1. And now we can do this calculation. And of course, it's easy to do, as you guys can see. I'm just going to do it in Microsoft Excel. So this is problem 3. And, I want to put all of the information in for this one. And so I am going to, yes, I am going to go ahead and say that this top one here is going to be our delta X, or compression length. Hopefully that will do. And this is going to be in, uh, I'm going to put it in centimeters, okay? And so we'll do the calculation for meters here. And I'm just going to wrap my text. All right, so we have our compression length. And I'm just going to go ahead and fill this to the right one. And we'll change this to meters. Of course, this is a very easy calculation. I also want to put in the tolerance, or uh, the I want to say error, but let's just call it error. And this is going to be in centimeters as well. And let me fill this to the right. And we're going to change that to meters. Okay, so I have those things. And I also want my force. So I should say, let me be a little bit more specific here. Compression length error, and of course that's what this is as well. And I'll just go ahead and make this meters. And then we have our force, and this is in newtons. And I am going to fill that to the right because I want my error that's associated with this as well. The error in the force, okay? So I'm just going to go ahead and put those numbers in real quick. And so for mine, I have 19.9 for the length in centimeters. And then I have, let me see, I do it in meters. So I have my compression error. I did not close that parenthesis. And this is going to be 0.199. And so this is going to be equal to, we know we need to divide this by 100 to get our compression length in meters. And then we're going to do the same thing here. This is going to be equal to our error divided by 100. Okay, spread that out a little bit. And then we have our force. Ooh, I did this one in the wrong place. Let me move this over here and let me just delete this column. And so our force is going to be, I'm going to have 23.2. And for this one, I have 0.232. Yeah. All right. So all of that is pretty straight. So if I want to calculate the spring constant, okay, the spring constant is going to be in newtons per meter. All we need, according to what we had before, is we need our force, and we want to divide that by the compression length in meters. All right. And so I am getting 116. It looks like we have three significant figures. So 116.6, that should be enough.